Now, coming to the tips to enhance the battery life, because so far we have seen that what are the shortcomings of the batteries, what are the problem of self discharge, the capacity loss, how the temperature is affecting the battery pack capacity. So till now, you have seen that all these factors are what they are doing. They are just contributing in degrading the capacity. They are contributing to all those factors which we till now have discussed are contributing in, or their contribution is towards reducing capacity of battery pack, reducing capacity and life cycle of your battery pack. But so in order to so there must be some good practices to enhance the life of a battery pack. So these are the some of the practices which we were discussing now in order to ensure the healthy life cycle and healthy life cycle and capacity and the ability to retain the capacity for a longer period. So now the first one measure is to not discharge the lithium ion too low and charge more often. And it is also always saying that the partial charge is fine. So considering the lithium ion, first of all, lithium ion batteries are never required to be fully charged. I am saying that lithium batteries are never required to be fully charged. So we are not required to charge the lithium ion in a full SOC state. And that is the best thing because the lithium ion functions very well in the state. So always keep the state of charge between 80 to 90, 80 to 85% for the lithium ion. So and if we talk about the discharging of the battery, so as I have discussed in a previous slide, that there was a level indication or there was a working range. There is an upper and there is a lower limit, and this was a working range. It was something 80% and this is a 40%. So as I said that generally it is a good practice that you do not discharge your battery completely. So always maintain some state of charge inside your battery. So it is always necessary to maintain the state of charge inside the battery pack. So it is also saying the same thing, that do not discharge your battery pack too low. So always maintain some state of charge inside the battery. So when you come below the 40%, just you should in case of your mobile phones, you should disconnect. You should stop using discharging your battery further and just go for plugging. Just go for charging and stop at 80 to 85% level. Do not go further beyond that because which ensures the good health of a battery as well as the lifespan, and your battery is going to retain the capacity which is being promised by the manufacturer for a very longer duration. So now, in case of electric vehicles, generally there is a provision. There are some circuit arrangements that you are not allowed to charge your battery above 80%, and you are not allowed to discharge your battery below 40%. So you are always operating with some depth of discharge, which is 40 to 60% depth of discharge is only allowed, and that's why they provide you a good range as well as the good range as well as the good life cycle. That's why they are able to keep promise with you. Now, as I've said, that lithium ion does not need to be fully charged. So a partial charge is always a good practice in case of mobile phone as well as in case of electric vehicles. In case of mobile phone, just always operate in this range between 40 to 60%, 40 to 80% or 85% also. But do not go for complete 100% charge or 0% or complete discharge. So always maintain this threshold, a lower threshold and upper threshold. Now coming to the temperature effect on the battery packs. So the temperature effect, if we talk about, as I've said that if the temperature of the surrounding of the battery pack is very high, so the problem of sulfation in the inside, in case of, especially in case of lead acid battery, is very high. And also high temperature affects the electrolyte as well as the electrodes of the battery. So their capacity is degraded. But so in case of lithium ion, there is a limit of 40 to 60%. So at lithium ion functions best in 40 to 60 degrees Celsius. But above that, they also start their capacity also start decreasing. And especially in case of low temperature or in case of freezing point below 0 degrees Celsius, lithium ion functions very poor. Lithium batteries function poorly. So their functioning is very poor. So lithium ion batteries are generally not allowed to be operated in a temperature in a very in a very low temperatures, and they function quite well in a high temperature. And some of the lithium ion cells are can even tolerate a temperature of 100 degrees Celsius and 150 degrees Celsius. So they are improved chemistries which are able to tolerate the temperature of they are able to tolerate high temperatures. And now the third step is limit the time the battery resides at 4.2 volts, especially when warm. So what it is saying that, so it is also saying the same thing, that do not go for the overcharge. What it is saying, it is saying that limit the time the battery resides at 4.2 volts. So when your battery is charging, the voltage, when your battery is accumulating charge during the charging process, the voltage of the cell is going high and there is an upper limit. So when your battery is completely charged, there must be some voltage, which in this case here is 4.2 volt. So if you constantly keep your battery pack, let's say your battery is completely charged, and still you are keeping your battery pack in a your the switch of your charger is on, and you are overcharging your battery pack. So the temperature of the battery pack is going to increase. So it is not advisable to do so. So overcharging should be avoided. Overcharging should be avoided. Overcharging should be avoided because when your battery is completely charged, then 4.2 level voltage is achieved. And if you are going beyond that, then you are entering into overcharging state. And the lithium ion batteries generally do not tolerate overcharge. Because at overcharging the temperature becomes very high. And if we discuss about the next step, which is the moderate current charge. Now the effect of charging rate over the lithium ion batteries, we have seen that, for example, in case of your fast charging phones, if I talk about the fast charging, then generally 1C rate is what? It is the charging and discharging rate. So what it is suggesting, the 1C is suggesting that you can charge your phone completely in a 1 hour if you if you charge your battery pack with the rated current. But generally it is not done, because if it is done, then if it was practiced actually practically, then every mobile phone would have charged within 1 hour only, or even less. Within 1 hour only, these mobile phones would have charged. But some of the mobile phones charge in 1 hour, or even some takes more time. But the healthy practice is to operate the mobile phone charging current at in this range between 0.5 to 0.8 C. So what you have done here is you have just reduced the charging current. Reduced charging current. What we have done here is we have decreased the charging current. So now the battery is going to take more than hour to charge completely, but there are some advantages associated with it. So first one is that the capacity, the battery is your battery pack is going to retain its capacity for a longer period, as well as the life cycles of the battery pack increases. So for initially, if it was 1,000 cycles of charge and discharge, so now for 0.5, now for 0.8 C, you can go up to 13 to 400, and even if you further reduce your charging current to 0.5 C, so what will happen? This will further increase your life cycle. So now you can go for even 2,000 cycles also. So generally, the charging current, or the good practice for charging your battery pack is between 0.5 C to 0.8 C. So here the current is charging current is just made half, and here the charging current, what you have done here, we have made it what we have just multiplied our current with the 0.8. So the current is now here is reduced. So generally, it is advisable to avoid ultra fast charging. And even the fast charging, which we see generally, they operate in this range of 0.5 to 0.8 C. They do not go for 2C or 3C charging, because ultimately, if you go for 3C or 2C charging, then in a very short span of time you can charge your battery pack, but it will have some consequences on your battery pack. So the capacity and the life cycle of the battery will be reduced drastically, and after using it for 2 months or 3 months, maybe there would be a fair chances that you have to replace your battery pack. So that's why this harsh loading should be avoided. So generally go for 0.5 to 0.8 C charging, not even 1C charging, because it will take some time, extra time. In a 2 hours, maybe it take 2 hours to completely charge, but it will ensure a good life cycle and good health of your battery pack. So now, whenever possible, lower the charge voltage limit to prolong your battery life. So we should lower the charge voltage limit in order to prolong the battery life. Now, keep the battery cool. Again, the effect of temperature, as we said, and the lithium ion battery's performance reduces at very high temperature. So generally, it is advisable to keep the battery temperature in a limit. It must be controlled. So whenever possible, we so keep the battery temperature in a cool state. So we should move it away from the heat generating environments. So as I've said that in case of electric vehicles, what we generally do, we provide the heat. We take generally heat controlling or thermal management systems, which are heat controlling measures. We generally use the thermal management systems, and these systems are very costly. But we have to use these systems, and we have to ensure the proper ventilation. We use coolants for our battery packs. So there are liquid coolants which are used, which flow between the battery packs in order to collect the heat. And we generally avoid the hot cars. And hot car is what we have to control the temperature inside the car, and also sun. in case of mobile phones, we generally we should watch for the exposure to the sun. So battery packs efficiency decreases as the temperature goes on, and after a long time, after a long period of usage, their capacity also goes down. So exposure to the sun should be avoided. So the measure should be taken to keep the battery in a cool state always. This is what we have to take it from here. So the temperature surrounding the battery must be cool, and proper heat, proper ventilation, proper exchange of air should take place, so that the heat radiated by the cell is not accumulated at the point, and it is distributed. Now, charging when stops when. So there are smart chargers also available. So what these smart charger do? So when you are charging your battery, its voltage is constantly increasing, and there is a point at which when SOC is 100%, as we have discussed in this point third, which the voltage which we have got here is 4.2 volts. So let's say we have reached the 4.2 volt. So there are some switches and controllers which keep watch for this voltage level. So they will be constantly monitoring this voltage level, and when you have reached, so when you have reached to this voltage level of 4.2 volts, they will automatically cut off. So what they do, they automatically cut offs. So they automatically cut off this 4.2 level voltage, and charging further stops. So automatically, when predefined voltage level of 4.2 volt is reached, the charging is further stopped, and it is automatically cut off from the supply. So now the problem of overcharging is eliminated through this practice. Through the use of these switches and controllers, the problem of overcharging is generally is completely eliminated, and the lithium-ion batteries which we are using inside the laptops are generally not required to be charged completely, and they function even within in a even when they functions, even their functioning is even good when they are not completely charging it. So partial charging is always a good practice.